Welcome to today's Mobility Forum. This is episode 149. My name is Jinghua Zhao, Professor of Cities and Transportation at MIT. Today, we'll talk about mobility data. Data is power, as everybody recognizes now, playing a key role in shaping the transportation system. Mobility data as an industry has seen remarkable growth with an explosion of new data providers. How do we ensure those data represent everyone's movement, including vulnerable users, non-motorized mode, and isn't biased by its source? How do you validate those vast data sets against ground truths? What level of accuracy is necessary and achievable for making critical decisions? And what are the main progress in the last, say, 5 years? Are we mostly on the data collection technology or on the synthesis and data fusion method or analytics using modern compute, prediction, causal inference, or is actually more on the use case providing real world problem? We're delighted to have Alex from Replica, Paul from StreetLight, and Ralf-Peter from TomTom to examine their distinct offers, different methodology together and integrate data source, address privacy, security concerns, share a few practical use cases, and explore how the industry will evolve in the future. Bhuvan designed today's panel, and I will invite Bhuvan to introduce the panelists properly and moderate the discussion today. Bhuvan, the floor is yours, please.
Thank you, Jinhua, and thank you, panelists, for joining us. Before we kick up, I'd like to just do a small poll, and I'm just launching the poll now, so I think most of y'all can see it. And we're getting the responses. Three very obvious questions. I work in the mobility and transportation data sector, or I use mobility and transportation data in my day job as a researcher, city planner, or in business, or I'm just a casual observer and interested to learn more about the methodology, privacy handling measures, some of the points that Jinhua just mentioned. I see we've got almost 180, so I'll just stop it in a few seconds. We are up to 50 people now, so I'm just going to end the poll right now. Okay. Y'all can see the results. So our audience is actually quite an aware audience in the transportation data sector. So 28% actually work in this sector. So that's wonderful. Your jobs are made much easier now, or maybe much tougher. You might get much tougher questions from the audience. 55%, half of them, more than half, use this data in their day job as a researcher, city planner, or in business. And 17% are casual observers interested to learn more about the methodology. And we usually do a warm-up exercise where everybody just puts in their location and local time, so you can get a sense of where the audience is joining from. So in the chat, if you have a look at that, you can just figure out. It's a pretty global audience. So I'll just stop sharing this. And so just to kick us off, we'll start. Let me introduce the panel, and then each of y'all can do a brief presentation, and then we can just get into the discussion. I'm particularly excited by this panel because it's a common cause of mobility data, but three of y'all do it with different approaches. And some of y'all actually are customers of each other, so that's even more interesting. So anyway, let me just introduce the panel. So let me start with Alexei. Alexei Pozdnoukhov is the co-founder and chief scientist at Replica. He has a PhD in computer science from EPFL Lausanne. Among his many roles, he was director of research at Sidewalk Labs, was assistant professor at UC Berkeley, and now is full-time as the chief scientist at Replica. We seem to be having a lot of Berkeley representation in this forum, with Alex Bayern and Scott Mora joining us in previous episodes. Moving on to Paul. Paul Friedman is the co-founder and CTO at StreetLight Data. Paul has started 3 successful SaaS analytics companies and built 4 successful engineering teams, also working at the MIT Media Lab and Oracle. And of course, Paul has a BS and MS in computer science from MIT. So welcome, Paul. Moving on to Ralf-Peter Schäfer, VP of Product Management for Traffic and Travel Information at TomTom. Ralf-Peter has been with TomTom since 2006, and in his current role, leads Tom's global product portfolio in traffic services, aiming to enhance mobility and reduce congestion. Schäfer has been instrumental in advancing applications for dynamic navigation and traffic management, and very interestingly leads the annual launch of the TomTom Traffic Index, providing congestion benchmarks for over 500 cities globally. I think everybody on this call has seen this TomTom Congestion Index, and we all of us look at this, has my city gotten worse or better? Ralf-Peter holds a degree in electrical engineering and has also worked at several research institutions across Germany. So without further delay, Alexei, let's start with you. If you can share your slides, then Paul, and then Ralf-Peter, and then let's get into the discussion. Thank you.
Okay, let me try. it's not always easy to
I have a backup
share.
just in case.
Okay. So tell me if you can see the slides really well.
Please. Says loading.
Yeah.
Oh yeah,
Good.
all good.
Good. Okay. Replica started as spin out from Google's Sidewalk Labs initiative. Alphabet wanted to build a city. And that was a very good attempt, actually, the waterfront of Toronto. That didn't end in the actual city. It was a prototype, but it ended up in many good spin-offs out of that initiative. The reason was COVID and other things, but Replica was one of the spin-offs from that. And we've built a model for the redesign of the waterfront. And then, okay, why don't we scale it up and build it for the entire United States? And so we did. And currently what we do is we get data from multiple providers, typical LBS data from cell phones, kind of location-based data from different apps that kind of resell their data exhaust. We get data from pretty much everyone, including the public sector. So we always validate on ground truth as well. And what we do is from this raw data inputs, we build several core data products. We call them core data products. It's synthetic population. It's a product on the land use, built environment, products on how people actually travel, and products on economic activity of how people spend money when they travel, purpose in the travel all the time. And we took an approach of modeling as a first principle. So we synthesized the population first. And the reason for that is with all the data that we consume, the data market changed so fast. First, and second, there's a real need to keep privacy as a first principle. So the only way to integrate all these data sources into a single layer that allows you to produce products is modeling. And so that's what we did. So we generate population. We literally take all census data that the Census Bureau provides and back engineer it into a disaggregated population. So we start with 330 million people. They are synthetic. That's got all the attributes that define their mobility profile. If they got access to vehicles, what age they're in, what income they got. We've got very detailed land use data. So we know where they live, what's around. We run a routing system that is truly multimodal. Takes auto, freight, transit, walking, biking. It's time dependent. We know what congestion level is on peak hours. And we can use it to assign travel, traffic, or transit, or whatever, appropriately to the time of the day. And then we take the location-based data, the LBS data, and from the single pings, define home, work, and shopping, and leisure, and whatever else things people do. And we transform every device that we observe into synthetic agent. So it's literally every device is transformed into what we call a persona. And there are millions of devices, tens of millions of devices that receive the sequence of. Now from the device, we have a model of how a person living in a particular neighborhood travels through the day. And the structure is somewhat classic activity-based modeling structure. So you train a model for the activity sequence through the day. So if their device is turned into how they plan their day, then they plan where they go on the location choice. That's the model. And finally, the mode choice of like how they're going to travel there. Because there's many constraints. If you leave the house on transit, like you can get the car out of nowhere. So you have to plan your days somewhat differently. So all that logic is been built in. And then all that goes into a simulation. And we run the simulations for spring and fall for the entire US. And that goes into the product that we call Places. And it's an activity-based travel model that is being built on the actual data from the actual time period, where every single household in US is represented as an agent, a synthetic agent, and the entire pipeline is being run by running this first inference from LBS data, second, the simulation, and third, the calibration and validation on the actual ground truth. So basically do it for every region. We compare it to the ground truth that we collect from public sector agencies. And we make sure it's close. It's actually quite close. Somehow people's patterns are very predictable. If you know where home and work is, and everything else is around that. But anyways, calibration is a very important step in the pipeline. So we run that, we produce that, and it's a product that represents a typical day every quarter or every season. And we've been doing it since 2019 to now through COVID. Now, one more point I want to make. Why we chose the modeling as the principal approach is because Places that we produce is a simulation or a scenario of a current day. But within the same pipeline, if you change inputs into that pipeline, you can produce a scenario of the future. So we take the same pipeline, we change the population, we change the road network, and we can produce a scenario of what happens if you close the freeway. What happens if the population here grows? What happens if you build more housing in a particular place? Where would these people go? And all that is possible because we're not just producing the fast forwarding the data. We have a very thick modeling layer in between the raw data and the outputs for the products. So this is what enables us to run scenarios. And then the second thing you can do with the same pipeline, you simplify it a little bit. Basically remove the computationally expensive steps of traffic or transit assignment that produce precise routes for every agent traveling. You remove it and you just present it as travel times. And you could build something that represents what happens over time every single week. And we call it trends. We run it every week, before COVID, after COVID. And it was very successful with many customers. So that's the other thing. And then finally, when you got like all that richness of data, we also started building application. So you could focus your data access to a particular use case that is of interest to you. Volumes on the network, ADT on the network, Explorer, anything you need to know. So there's many examples that we can go into place.
And Alexei, I'm sorry, but I think we're just running out of time. So we'll probably come back to some of the methodology and privacy questions once the others have also presented. Or if you could start sharing slides so that, thank you.
Sure, one second. Let's share the screen. Okay. So StreetLight Data. Who are we? What do we do? Etc. So StreetLight Data, we've been in the game for 14 years now, which I still can't believe. Our mantra is using big data to make transportation better. Across that time period, over 1 million transportation projects have relied on StreetLight Data's analytics, data, etc., to help them make better decisions. That's the name of the game. Is historically in this industry, people were making decisions using very little data, maybe just small road surveys, maybe just a couple guys with clipboards, maybe just somebody who has experience. And yeah, many $1 million, $1 billion decisions came out of this. So our mantra has always been shining light on this, bringing actual real world data into the market to help us hopefully make the right decisions and make the world a better place. Some statistics, since the topic today is data. We process over 7 billion trips per month. In our data stores, over 5 petabytes of trip data. And the run rate right now is roughly 20,000 analyses are being run by transportation planners, modelers, etc. each month. So this is the sort of broad swath of all of the products we have in the market. It's too big to discuss in 6 minutes. So I'm going to focus on the orange, yellow column, the mobility data. This is a new set of products that we're offering where we're taking the sort of, I wouldn't use the phrase raw data, but we're taking actual mobility data, privacy, protecting it, enhancing it, and offering it for sale to customers who have the capability of ingesting that type of data, as opposed to from the other columns, customers who really would rather just have the answer to a question that they want to ask. How many vehicles went down this road last month on a Wednesday? That's the answer to a question, as opposed to show me all the GPS pings of the vehicles that are going down this road and all of the paths that they were taking to get to the road and where they went afterwards. So we're focusing on the mobility data today. Needless to say, mobility data is big data. So what are some other examples of classically big data? Visa processes 750 million transactions per day. In the Christmas season, that goes up significantly, but still it peaks at about 1.1, 1.2 billion transactions a day. Google, people search for stuff more than they buy stuff, so that's good. They process about 8.5 billion searches per day. We ingest about 15 billion raw GPS points per day, and I'm sure Ralf-Peter will show some similar if not even bigger numbers from TomTom. We're also customers of their data in addition to this data that I'm talking about as well. And yeah, the market is very interconnected. In fact, early on in Replica, we sold Alexei some data as well. So the industry goes back and forth. We're all customers of each other. We're all partners of each other. We also all compete with each other on some of the deals in the marketplace too. Let's dive into this transportation data a little bit. So about 15 billion points per day averaged across a week. It comes from a little over 10 million vehicles. These are actual vehicles reporting their location every 3 seconds in real time to StreetLight Data. It represents about 39 million journeys, where we use the word journey as in ignition on, you drove somewhere, ignition off, you get out of the vehicle. Very valuable, very interesting, very powerful data set. Very hard to ingest too. Just it's a fire hose of data that's just coming at you relentlessly. So we offer this in the market either as a national data set. We have customers that subscribe to it that way. We offer it to as state or regional data sets. If you just want the fire hose from say Kansas, we can get you that either in real time where it's sub-second latency from when we get it to daily batches of flat files if customers want to ingest it that way. And many of them do, because it's really hard to build something that keeps up with these types of pipelines. Even in today's cloud computing environments, it's still pretty tricky to get compute to flow like that. Some more statistics. Like I said, 10 million vehicles. These are all modern-ish vehicles, 2015 and later. They need to have GPS navigation inside them. The fleet breakup is about 55% SUVs. Americans love their SUVs and pickup trucks, boy. And 15% classic sedans. On average, vehicles are active about 25 days per month. Our penetration rate has been growing over the years. It depends on the biggest factor that the penetration rate seems to depend on is actually the volume of the road. We have really good penetration across the different road types, but classically between 3 and 5% is where the data lives right now. And we found that to be plenty good for almost any type of analysis you need. Another data set that I wanted to highlight here that's important, Alexei talked about ground truth. We think it's critical. So one of the things we do is we monitor all 14,000 counters, traffic transportation counters, embedded into the road networks of the United States daily. And so that, again, these feed into the analytic products and into the analysis products that StreetLight makes in those other columns. But it's also a data set that we can and could offer for sale to advanced customers that want that, because acquiring that data is, shall we say, tricky at best. Every state, every region seems to publish things differently and do things differently. So data privacy, we agree 100%. Data privacy is critical in this market. Nobody wants to be tracked. Nobody wants to be stalked. Nobody wants to be followed. So we take great care of this. For instance, we send out no identifying information, no vehicle ID, no VIN numbers, no names, address, phone numbers, or anything identifying like that. But as we all know, just a location trace or a location travel diary alone, that can be identifying. And so we take great pains to identify that too. For instance, we do favorite location blurring here. So every 30 days for each vehicle, identify the top 5 most frequently visited locations. And then any point in the data set that is within a half a mile of any of those top 5 locations, the precision of that data gets truncated to just 2 decimal points. which is effectively gridded to a half-mile grid in North America. So you can't identify the home, you can't identify where someone works, you can't identify their kid's school, where they shop, etc. You can see what roads they drive on, and you can certainly see things like speeds and time of day and things. But in terms of figuring out who they are, can't do it. The second thing we do is what we call low density filtering. America has a very significant rural population that lives in low population density areas. So any time we see data points in a half-mile grid that's only saw 2 or 1 vehicles in a 3-month period, we just filter that data out. So if somebody lives on a farm out in the middle of the country, their data is not going to be in this data set. It's obviously, if you saw those points, you would know who it is. They're the only farm in the area, they're the only house in the area. We think that this is where the industry should be going in terms of protecting both privacy, but yet preserving the fidelity of the data so that good science and good analytics can be done from that. Some statistics about that privacy protection, and that map is a little bit of an example of a blurred trace. So that is to scale. Those are half-mile grids that are blurring. If that was a trip that started at someone's home, drove by their kid's school, and then ended at work, all the points in those grids would just be truncated and would all be the same. And so you couldn't figure out where within the grid they lived, where within the grid they worked, or where their school was. And it's a significant percentage. But obviously people tend to drive to and from places that they live, that they work, that they frequently visit. We are, as Alexei said, creatures of habit, and that's completely true. So roughly 20% of all points in the data set are blurred. About 23% of the trip ends, what we call the key on and key off events, are blurred. And 14% of the trips have both ends of the trip blurred. Yeah, it's protecting privacy is more important than having the raw data. You can still do good things even with this blurred data.
Paul, sorry to interrupt.
Yes.
So I know that you have two really good slides, but I would ask Peter to present first, and then we'll come back to the heartbreaking.
Sure. Okay.
Yeah. All right.
All right. Thanks. Then let me share my screen. I hope you can hear me well.
Yes.
Okay. So can you see my screen now in presentation?
Mhm.
So to start, Tom is meanwhile a B2B company producing digital maps, navigation software, and services. And based on the strong success 15, 20 years back on using sat-nav devices, we created a strong community of the people using our software and services, and in return received a lot of probe data. Paul spoke also about the data revolution, which is happening still. And we are really on a stage where we have a lot of data, very diverse data for changing the game. And Tom is also on a mission next to navigation services to help governments and businesses to use the data in a proper way. In the beginning, it was already mentioned we are producing with the data for 12 years already a congestion index. And interestingly, there's always obviously an increase of congestion, but with the COVID situation where we had really empty streets, a bit of a change happened that in cities traditionally were very congested, like Los Angeles or New York City, fall really behind on congestion level. But now in the last 1.5 years, we're seeing a trend that the working from home is melting, right? Companies calling back people to office, and it changed the pattern of congestion and demand. And we see it also in our data. In particular, in cities with the service industry, significant up ramp also in the US, we're seeing San Francisco and New York City going up again in the ranking. So this is an interesting phenomena we are observing. Big data is a topic for me for 25 years. I started to deal with probe data, even in research, dealing with probe data from the year of 2000. And meanwhile, we have built a very strong community based on navigation services. And in all major markets, we have typically more than 1 of 5 cars reporting probe data to us, what we utilize in services. But growingly in the last 5 years, with the revolution of the ADAS system and cameras in the cars, we also utilize camera-based observations. We have sign information for our mapping. We can create incidents, and this is also a real-time play on top of GPS. But what I want to talk is really what we're seeing as a big trend is a revolution in traffic management. And the classic competing ecosystem of automotive navigation and transportation management, a classic government play, is merging together, and the players starting to collaborate. That is really exciting. And we are really on a revolution to change the game and using more data, what Paul already mentioned. In government, often big decisions are happening without data. And this we want to change. And there is enough data available. The big dilemma of congestion fight is this typical triangle between the network capacity, modal split, traffic demand. And with the data we are collecting in our StreetLight, we are trying to build products to help to understand these triangle relationship. And Alex spoke about synthetic population and simulation. Capacity is a very complex and critical thing to understand the behavior of people in the network and how to simulate in a proper way. That's a classic and very hard problem to solve. But the data we are getting there to high penetration, we can really get closer to this problem. But we also working on products, not only congestion fight, but also to increase road safety. We implementing hazard warning service to make safe speed in navigation available even on ADAS car. That is also a topic in TomTom. To give you a glimpse, what does it mean, big data in our community? This is an example, a couple of weeks in New York City, that you see in congestion pattern on the I-95. And you see what density of probe data contributing in our community. So here you can round about 1 of 3 cars reporting speed information to our fusion engine, how we call it. And for those are a bit more nerdy on traffic engineering, this is a classic time space diagram where you really see the textbook structures of congestion, the stop and go pattern, jam tails, in the classic ways you can observe in the data, which is incredibly powerful to provide prediction algorithms, but also understand congestion pattern. And still, it's still a hard problem. Predicting traffic is a big dilemma. When you get into information to the people, they also destroy your prediction. It's not like weather, it happens, whatever. Prediction has a feedback loop, and this makes it so complex to make it good, right? So what's important also for us? The data play is in full steam, right? But what really we want to achieve, even in the government, is not about understanding a problem. We want to create impact. And this is the time to create impact. We are on a revolution on traffic management and planning using data and really closing the loop. And this is one big theme in TomTom and StreetLight and Replica. We want to really close the loop and measure and create impact. And we have all the ingredients. And there are a couple of good examples. Here's a use case we're doing with traffic light controller company in Japan. They used our data and compared it with local measurements from loops, from infrared, and they came to the same conclusion on the data input than from infrastructure. And they can optimize with probe data, traffic lights, and you can feed it back in the ecosystem of navigation to provide better network data, optimize, and also give proper speed advice in any context. So there's another dilemma. It's probably good to talk. All navigation optimization today is selfish. What we're doing, what navigation is doing, what is Google, the TomTom, the Apple, everybody's doing, they're optimizing delay in a selfish manner. This model can't work in the future. We need to think about a different optimization criteria from the network perspective because information is there. Everybody has the same information. It creates a dilemma of information, and that we need to resolve. In some markets, you can see it very good. Let's say in South America, Sao Paulo, you have a monopolist of navigation systems. And with the small streets become suddenly in a selfish mode very attractive, and you create gridlock jams just with the classic routing optimization. This is, we have to reconsider and rethink how we managing networks in the future. And ADAS and autonomous driving is something what even increased this need for a new way to look into optimization of travels. But we also want to look into impact. We want to see what's the change when combustion engine go to EV. We can better have information about CO2 transformation with volume data, with good dynamic data. The modeling capabilities today are available as much better than years back. And it is also good to understand the impact of change. Same, it was mentioned by Paul, road safety is the big thing for TomTom in terms of the ADAS navigation, in terms of speed, recommended speed in any context, but also understand what hotspots of where people overspeed or the infrastructure is insufficient or have risks. And this we can also see in data. And this is also an interesting use case to help the government and businesses to improve safe driving. Just a few examples. I want to stop here and then let's have a good conversation on some classic problems of the domain. Thanks.
Thank you, Ralf-Peter. Do you want to offer some quick commentary before the discussion?
Sure. Yeah. Thank you, Alexei, Paul, and Ralf-Peter. I was still digesting the talk, trying to integrate those. Maybe I'll offer 3 observations, right? The first one is from an individual level, who owns the data, right? Let's just imagine I'm a regular commuter. I'm using Google Map on the iPhone, using a Verizon service, driving a Tesla on I-90 Turnpike financed by Mass DOT. In this case, who has a claim on my data? Google, Apple, Verizon, Tesla, Mass DOT? In practice, seems all above have some collect my data, use it, except myself. So who defines the property right of data? Who produce it, aggregate it, transact it, consume, analyze, and destroy data? Who benefit from it? Who make money out of it? So that we can enable a healthy market-based transaction. So that's the one question. I'm puzzled about it. I'd like to hear the panel. What do you feel about it? So that's the first observation.
I
The
think
second one-
if you didn't pay for the product, you are the product. Should there be a toll on every single road and then the roads offer you money? I don't think that's going to fly.
Yeah. It's a question. I just say, who should define the property right of that data? This
Yeah.
among all these different parties, how do you allocate this property, including the user itself?
It's quite difficult. The objective function for all the companies who actually got the data is getting consumers into their product. So when using Google Maps, they make everything possible to keep you engaged with that product. That's it. That's the only thing that they want. So if we're talking about the value to public sector or for long-term urban planning, nothing is going to come from big companies. Google tried. Like, honestly, Sidewalk Labs really tried.
I see. Thank you. So that is the second observation, which is the balance between the public sector data, private sector data, and open source data, right? If we say 20 years ago, who owns transportation data? You'll say DOT owns it, MPO, the planning organization owns it, maybe city owns it, right? 20 years on, I think the quality, the public sector owns the data, probably roughly the same. But the private sector data really exploded, dramatically increase in the private sector data. And also then we have the open source data. There's at least some attempt to have this open source data being a lot of effort there. So that's the second question. How do you see the balance between the 3 groups evolve? What do you see into the future? And would some sort of a transaction between the 3 group of actors play out in this? And let me just maybe finish all my remarks and pass on there. The last one, I want to give a concrete case, right? New York City just introduced congestion pricing, maybe the most significant transportation policy ever in the United States, right? I want to offer an example from London, England. When they had this congestion pricing in London, they introduced a systematic monitoring program, continued for 6 years. This is the 6th annual report from Impact Monitor. I want to mention what they cover in the monitor report. They talk about traffic pattern, of course. They talk about congestion. They talk about public transit, traffic collision, air quality, behavior change. They talk social impact, talk about business impact, economic impact. Really a comprehensive report on this, right? First of all, I hope that New York can do something similar. But the question to the panel is, if your company were hired by New York City to do such a report, which part of the report you think your company can just do it by yourself? Which part of the report you need to collaborate with the other party or other company to really construct such a comprehensive report? That's all from me. Thanks. Back to you, Bo.
Well, there, I can start. There's many aspects here to your statement. The first thing is about modal split management. Congestion charging is one way to manage modal split. So it's penalizing the road and incentivize other modes of transport. This is one way to do it. But there are much other ways. You can improve the public transport sector. You can improve parking, different way to do it. And there are many examples to manage modal split. On the data side, I believe data is massively available, and there's a phenomenal growth of open data, which is good, but also on availability in a non-discriminatory way of data. You can even license. And this will mean in the future, the competition is less on the data side, is more on the algorithms, on the solutions to create this impact I was talking before. Data is growingly available. We want to work and challenge ourselves how to use the data for better decisions and creating this impact. And it is about algorithms. It's about solutions we have to build on the data, right? And this is where the future competition will change who wins the race.
Paul, anything to add, or I can quickly jump in with a couple of questions that I had?
Yeah, in fact, New York City is a customer of StreetLight Data's. They've used our data in the planning for many years of the congestion zone. They've been using it to analyze the results of the congestion zone. And I know they use other commercial data sources in that as well. Call me the real world curmudgeon. I think in the ivory towers, the concepts of data ownership and data transactions and such are just not terribly practical or practicable in the real world. Data is collected by the people who collect the data, and then they do their best to make sure that all the participants are knowing and have opted in and signed up to the best of their abilities. I'm sure nobody here has ever read the shrink wrap license when you first buy a car and you tapped yes on your navigation system as that long document scrolled by. But thank you very much for saying yes.
Paul, if I could just add to that, in the last 2 years, we've had the downfall of LexisNexis and this whole GM fiasco on connected car data, who owns it, that it should be an opt-in policy and not an opt-out policy, because finding where to opt out itself is a big adventure for the customer. So how has this impacted your data flow, for one thing? And maybe I'll just tie this in with my second question. You said 10 million cars out of a 285 million car park in the US. So do you think that's a sufficient representation, given that it's mostly 2015 and newer models? So you're not looking at used cars that, the lower economic classes buy, and are they being underrepresented? I'm not even getting into like non-car modes, but folks who buy used cars and their travel patterns are being underrepresented, and folks who buy the newer cars their travel patterns are being looked at by the system.
Oh, definitely. And the U.S. auto market, or the U.S. vehicle fleet, turns over approximately every 15 years. That's roughly the longevity of a vehicle. But no, we always normalize our data to those counters, to the ground truth, to pump up the underrepresented vehicles. There are way more pickup trucks in Texas than there are in California, or at least the San Francisco part of California. And all of that gets modeled. We also offer bicycle data products, pedestrian data products, truck data products. I was just focusing on the motorized vehicle, civilian ones there, but all of that gets blended and put together.
Okay. Ralf-Peter, so there's one question for you. Yesterday, we saw the announcement of Apple Car Ultra for integrating into the car totally, and Google introduced Google advanced version of Android Auto, which takes care of navigation and everything else. So are you looking at threats from the OEMs where initially they were incorporating your navigation, but now it's all managed by Google and Apple and people just use their phones? So is that a threat for Tom that your data sources are being taken away now with this integration?
So there are still two ecosystems, right? One is the classic mobile phone application, which is then mirrored into the screen.
Yes.
But the trend is coming really from the ADAS system, right? The deep integration in the car and integrating deeply the canvas with sensors in the car. This is the play happening at the moment.
Yeah.
And this will drive also business beyond the mobile phone navigation spectrum, what is addressed by Apple and gas and this classic navigation, right? So there's even a growing business for TomTom. We are working big time at the moment creating maps for ADAS and high definition maps for autonomous driving, where even the market size is much bigger as ever before.
It's not just the head unit.
All right. Yeah. So Alexei, I've used your product a couple of times and I use it a lot for the active modes, who's biking, who's walking. The numbers are really small. So I'm just wondering, given the usage of bikes is something that it's difficult because there's no like digital, how do you track if the phone pings are this guy's on a bike versus is he walking or is he in a bus? So just some.
I think active transportation is a thing of itself. It's very difficult to ground truth. And most times when there is a big infrastructure project for active transportation, say I build a bike lane that is cost me $30 million. Put a sensor on it. You already know how many people use it. You already know, okay, it's recreational cycling on Saturdays.
Yeah.
I don't think big data can help. Obviously, we can help when there's no sensors and no things like that, but it's a problem that needs to be solved by the local authorities.
It's true. While we have 14,000 vehicle counters, the number of bicycle and pedestrian counters and the fidelity of them is really poor. If you were to encourage your local governments to measure things, and not just the recreational ones, you got to put them where people are commuting up by bicycle, where people are walking in the cities. It's woefully underinvested.
Okay.
Absolutely.
I'm going to give John the impossible task of curating the audience question in 5 minutes. I know Alexei has been active in the chat, but yeah, John, over to you.
Okay. At MIT, there's this expression that at MIT and other research universities, data is like candy. So we have these 3 wonderful candy providers. We had 320 people at the peak and probably the most active chat that I have ever seen. So first of all, we will share this file with you. Some of you all have already been typing in your responses, so thank you for that. I'm going to try to just hit some of the general questions. Very early on, Darton Ito asked the question, do any of these data sets include vehicle occupancy information? And Kara Kokelman asked a sort of similar question, does anyone have a good way to put travelers together in an agent-based travel demand model? Most people model at the household level, but some people can travel with anyone for school trips, etc. So any general responses on that question about how do you model people traveling together?
Household coordination is difficult.
Yes.
So we do it at the level of bringing kids to school and other activities. But like occasional coordination, like you get a carpool from your family member going back from whatever you do, it's very difficult.
And remember,
So-
you can't track kids under the age of 13. That's just flat illegal and has to be removed from data sets. So,
Oh, yeah. Yeah, all
finding
kids under that
actual-
age are synthetic.
Yeah.
Entirely
Everybody
synthetic.
says that you want to find how many kids go to school, but you can't actually have the data of how many kids go to school.
Alain Chiaradia asked the question, are walking and cycling counted by anyone? If not, why not?
As I said earlier, they are, but it's underinvested. We have a data set of all the bike and ped counters in the US, and we offer bike and ped analytics, but it's not to the fidelity of the vehicle data. Also, I would say in the United States, outside of the top 5 urban cores, nobody walks and nobody bikes. Just let's be honest. Europe has figured it out. They have the density.
Europe is a bit different play indeed, but here still the underinvestment in tracking is a problem, collecting the data. But they are growing the providers of services, bike services, scooter services, with GPS. So there will be a bit of change, but it will take a bit of a while before we are at the same level as for the car at the moment. But it will come, I'm sure.
So James Nissenberg posed a question to Alexei, but I think it's relevant for all the panelists. This is a very simple question. What is synthetic data?
Almost all data that we use, right, is modeled. You observe something, you start, it's almost like a Bayesian approach. You start with the model, then you inform the model with the data. So there's not actual difference between synthetic what's real. Everything got some level of modeling introduced into it. All question is about how can you validate that your model is correct against ground truth. There's no. I think it's actually a very good question, but I would turn it into this dimension of how accurate your model is answering your question. Rather than like think, is it real, synthetic? Everything is synthetic. Everything is model.
Paul, Ralf-Peter, anything to add to that?
I think synthetic data is important to have really a good simulation design. Traffic demand is a general account, right? What you want to do is really make a representative population which have a good view. What is a commercial driver? What commuter type you are? Is it really represent the behavior in a city against the ground truth, right? And that's why this modeling is very important to have good simulation design, even to anticipate the future, right? What we can do today well is looking back and looking in real time. But the looking forward needs a good simulation model and a good representation of the population of drivers and how they behave. And this is really critical and also very difficult to have the ground truth data, what Alex talked about, very difficult.
Yeah.
Super. Paul, any just last closing thought for us?
This data is the future. And I think the biggest trend that I'm pleased to see is that the acceptance of using data to make decisions and to validate decisions has grown. The infrastructure bill that Biden passed included a section on that saying, it's just a thematic section, it's not a requirement, but it says all US DOT the infrastructure changes must be validated with data and must show their impact with real data. And that itself, that's the biggest change. And that's the biggest benefit out of this. Let's do things knowingly and measure twice, cut once.
Great.
Fabulous.
Thank you so much. Sorry to interrupt the flow. This is such an important topic here. I really thank you, Paul, Alexei, and Ralf-Peter, join us, sharing with us many of the insight, also frank commentary is the status quo of the data industry and also the future we're moving into. Particularly that we are facing kind of a dilemma. From one side, we have so much data, 15 billion record coming every day. At the same time, so little data in certain critical area of this, right? How does the industry come together to really move into this? Everybody join me thank Paul, Alexei, and Paul, Peter